So this video is notes part 2 on converting units. I'll preface this with the fact that this is probably my students' least favorite and sometimes most difficult skill all year, all semester for us. However, it is really something that we will use every single day in physics. And it's the skill of being able to convert units or transition things, for example, from feet to inches to meters to centimeters. It's something that we do in physics all the time that we need to do because sometimes we measure things in hours and we want them in seconds. And sometimes we have information in kilometers per hour and we want it in meters per second. Now the why is hopefully going to get you on the team of why it's important to be able to do this skill. Yes, you can do it on the internet. Google has magical conversions that are great, and we will use them, and you can use them. But I want you to be able to know where it's coming from, how to do it, and eventually to be able to do some of this in your head without having to open up the computer, Google, and just be able to do it a little quicker. What it does is it gets everything in the same language so that we can use physics equations. So our physics equation that we know right now is that velocity average is equal to distance or displacement divided by time. Now, let's say our velocity given in the problem is in miles per hour, and our time is in seconds, and our distance is in meters. Will this work? Is this the same language? No, we have seconds and we have hours. We can't use those numbers. We have meters and we have miles. We can't use those numbers. Things have to be in the same language, everything in meters, everything in seconds, before we can use a physics formula. So it's really important to be able to convert these different things. This picture is just showing an example of how we're going to do this. It's about crossing out units. You've done this before in chemistry. And so we're just really going to spend this lesson on it in terms of how you do it. And then we'll do a lot of examples throughout the semester. The next slide goes over some helpful equalities. You don't have to have these ever memorized, and we'll use ones other than this, but this is just some of the most common we'll use. 1 inch is the same thing or equals 2.54 centimeters. 5,280 feet equals 1 mile, and so on and so on. One of the most important ones that we'll use a lot, 1 meter equals 1,609, 1 mile equals 1,609 meters. Also, something to remember is that there's multiple ways to get from one unit to another. It doesn't matter how you do it or which way you take, as long as you're following the right rules. We will look at double conversions as well. What I mean by a double conversion is going from something like meters per second, where there's 2, to miles per hour and vice versa. That's what I refer to as a double conversion. This is just an example to have in your notes. And then we're going to use something called the metric prefix scale, which looks like this. This gets us from different things in the metric system. We'll talk a little bit more about that too. So just keep these things in your notes nearby, but really we're going to do our work in this virtual lesson in the problem set. So open up your problem set to where we left off. We're going to be on number 3 from last class. So number 3, you might be able to do in your head, and that's because I want you to be able to connect converting units in physics to converting units in other aspects of your life. So someone might ask you, how many dozen donuts is 24 donuts? 2 dozen. But my question for you is, how did you do that? What if I asked you how many donuts is 2 dozen? 24. So how do you know when you're dividing and when you're multiplying? So one helpful thing about converting units, we're never doing adding, we're not doing subtracting. It's always either multiplication or division, or both. But how do you know when to use one thing over the other? And that's what practice is going to help do. So the method I'm going to teach you, I call the line method. As I said earlier, there's multiple methods. If you find a method that works for you that is not this method, that's fine. I just care that you can do the skill, not that you can do it my way. So my line method begins with writing what the problem gives you. So 24 donuts, for example, is what I'm given here. I'm just going to do DN for donuts. Next step, draw a long line. That long line represents division. Okay, next step, draw a line like this. Okay, then what I have on the top, I write on the bottom. Because as you can see in your notes where we're trying to get, if we have something on the top, our starting amount, and we have something on the bottom where we're going to write equal amounts, those things can cross out. Ultimately, that's what we want to do. We want to cross out things that we don't want to achieve or get to our ending amount. So, donuts on the top, I'm going to write donuts on the bottom. Then I'm going to think, what is an equal amount thing I know about donuts? Well, it involves dozen. I know that there are 12 donuts in 1 dozen. Okay. Once I've got something I can cross out, I can do that because it's on the top and it's on the bottom. That leaves me with dozen left. Let's say dozen is not what I wanted. Well, I'd have to do another step. But dozen in this case is what I want. So I'm done. I take my top numbers, 24 and 1, and I multiply them. I divide that by my bottom numbers, 12. That's how I can figure out that it's 24 divided by 12 and not 24 times 12. Ones can be ignored. So if you have a 1 like we do there, we can actually just really erase it. Then we have 24 divided by 12. That's how we get our 2 dozen. Let's try one a little harder and a little more related to physics. How many feet equals 36 inches? So step 1, I write what the problem gives me as the number, 36 inches. Line, line. If inches are on the top, inches have to be on the bottom. What is something I know about inches? Well, we know several things. If you look in your notes, it says that 1 inch is 2.54 centimeters. Could we write that? Yes. Would that help us that much? No, because we're trying to get to feet. So do I know something that involves inches and feet? Yes. There are 12 inches in 1 foot. Inches can cross out, leaving with feet, which is what I want. Because feet is what I want, I don't have another step. Equals. Top number, ignore ones, divided by bottom number. 3 feet.
Hi.
It's okay. Say hi to Miss Tran, everyone. So next one, same method. How many seconds are there in 1 year? Well, 1 year. Start with 1 year. Line, line. We're going to want to get rid of a year. So year on the top, year on the bottom. What's something we know about a year? Do you know how many seconds are in a year? I don't. But I know that in 1 year there are, what's something we know? Maybe days, maybe months. I know days, so I'm going to do that. 365 days. cross out year. Now before we were done, but days is not what we want, so we're not done here. We need another step. Days on the top means days go on the bottom. What's something you know about days? Well, I know that in one day, there's 24 hours. Days go away. Hours is still not what we want. One more step. Hours on top means hours on bottom. I know that in 1 hour, there's not 24. There's 60 minutes. Hours go away. Minutes. We're getting closer. What's something we know about a minute? Now we know there's 60 seconds. So we just took kind of a big jump in those last two problems, but notice that our method really didn't change. So double check. Hours, hours. Days, days. Minutes, minutes. Year, year. They all crossed out, leaving seconds, which is what we want. Now, we take all the top numbers. Remember, you can ignore the ones. So the top numbers were 365 times 24 times 60 times 60. Divide it by all the bottom numbers. 1, 1, 1, 1. 1, we can ignore it. Ones. So really in my calculator, I'm just going to multiply 365 times 24 times 60 times 60. That big number is how many seconds, oops, one more zero, are in 1 year. Kind of a lot. And we used, not wasted, some of them to calculate that. Isn't that fun? Okay, let's keep going. If I'm going too fast for you, pause it, rewind. I'll also be posting some extra practice on the below this video on the original page in Canvas. Go through that extra practice if you need to. All right, next one's the best one because it involves Russell Wilson. So Russell Wilson, this is a true fact also, is so awesome that he not only rocks football, but also baseball, and he played Major League Baseball before he was drafted into the NFL. For those of you that don't know, Russell Wilson is the quarterback of the Seahawks. That's him. His wife is Sierra, and they had a baby this last summer, and guess what they named their baby? I think this is so ridiculous. It was a boy. They named him Win. Ugh, it's so obnoxious. Okay, I'm getting distracted. He can throw a pitch at 98 miles per hour. 98 miles per hour. That's what we're starting with. How fast is that in meters per second? Okay, now I want you to recognize something here. Miles per hour, meters per second. These are representing doubles. How do I know that? The per, okay? So what that really means is we're gonna rewrite the beginning. So 98 miles per hour means that you're going 98 miles in 1 hour. Okay, now a double problem is really just the same as two singles together. If you wanted to go and do 98 miles into meters, just like we did on number 5, and then do 1 hour into seconds, you could do them as separate problems, but I'm going to do them together to save time. So I'm going to do miles first. What that means is I am going to pretend. Let's actually use gray. I think that'll be easier. I'm going to pretend that that hour doesn't exist. Okay, and then I'm going to go back to it. So 98 miles, miles on top, miles need to be on bottom. I look in my notes to think, well, does it give me anything in my helpful equalities about miles and meters? Yes. 1 mile is 1609 meters. So 1 mile is 1609 meters. Let's say instead you accidentally did 1 mile into kilometers. Then you could go kilometers to meters. You could go 1 mile into feet and then feet to meters. You can do this with multiple steps in multiple ways, but I'm going to do it with that one. So I'm going to cross out. Miles gone, miles gone. Meters. Now, meters ultimately is what I want. So I want to keep the meters. So I'm going to keep it. I'm going to do a line. Now what I'm going to do is I'm going to look at the hours and I'm going to ignore and pretend all the other stuff's not there. So 1 hour. If hour is on bottom, hour has to go on top to cross out. That's a really important point there. So ultimately we're trying to go from hours to seconds. So I know 1 hour, 60 minutes. Hour on bottom, hour on top cancels out. Minutes, not quite what I want. Minutes on bottom, minutes on top. 1 minute, 60 seconds. Seconds is what I want. Now I have to uncross out what I did at the beginning because those numbers do matter, but I was just sort of ignoring them to make my visual cleaner with my line. All right, top numbers, take them all, divide it by the bottom numbers. So what are my top numbers? 98 times 1609. Remember, if you have ones, you can ignore them. Let's say you forgot though. Let's put in times 1 times 1. Well, that's fine. You can write them in there like that. So then we have 1 times 60 times 60. At this point, if you did write the ones, maybe now we erase them to make it a little easier. Or maybe you just keep them in there, but it's kind of cleaner to erase. All right, now I'm going to take on my calculator 98 times 1609, and I'm going to divide that by 60 times 60. Now, be careful how you type this in the calculator. I want to show you a wrong way. Look how I just typed this in. I did the top numbers, answer divided by 60 times 60. Well, that's doing the incorrect order of operations because those two things should be in parentheses. Okay, another wrong way. Can't write it like that. Now, we could use parentheses to write it. That would be correct. Or we could go 98 times 1609, and then 60 times 60, and then do 15,762. Okay, so, oops, how did I mess that up? Oh, I forgot that. 8 there. So there should have been an 8 there. 62 divided by, there we go. Either way is fine. If I were you, though, I'd probably use that parenthesis way. That's the most seamless. So our final answer is 43.8. Remember, that's in meters per second. Awesome. So that's converting units all using the line method. We are now going to use that metric prefix scale that you saw on in your blue notes. Okay, we're going to dive into how we use that, and then we're going to be done with converting units. So the metric prefix scale is this big fancy thing. Let's first just kind of look and see what's going on with it. So the first thing I want you guys to notice is this is the metric system. So kilometers, meters, grams, liters, those are all things in the metric system. Pounds, ounces, things that you're more familiar with are our standard US system, but it's not what science uses, and it's not what the entirety of the world uses. Okay, so that's one thing. The other thing is this word prefix. A prefix means that it comes before, my gosh, or at the beginning of a word. So let me give you an example. Centimeters, kilometers. The metric prefix of those is the first letter that comes before. Okay, another example could be kilograms. The metric prefix is the K. Another example would be like a gigabyte. The metric prefix is the giga. Okay, so milliliter, the metric prefix is milli. All those, the first letter is the prefix that we're looking at. Okay, now I want you to look at the scale. Notice a few things. The prefixes are the letters that you see there, or down here too. The word is the next thing, so C stands for centi. Now 10 to the negative 2 means 2 places to the right. So, but sometimes it'll mean the left. But essentially it means centi is small, that negative there. So the steps to using this scale will help you. And if you don't like that 10 to the negative 2, honestly, you can kind of ignore it with the steps that I'll show you. Last thing I want to look at here is this none piece. So what is that none in the middle? It represents the base unit. So it represents just grams, just liters, or just meters. Those are mainly the ones we'll use in physics. So now what are the steps to using the scale? Well, the steps are in your notes. So flip through your blue notes to find the slide with the metric prefix scale and see that you have those steps there, okay? Now I'm gonna rewrite them here just to go through them and also to kind of shorten the steps a little bit. So in your notes, blue notes, it says step 1, find the prefix of the number you have. Okay, so find the numbers prefix. Let's actually do an example and see what does that mean. Well, for number 7, the number you have is 1,000. What's the prefix of the 1,000? Nothing. It just said grams. So it's the none. Okay, so that would be step 1. Then I would kind of put my finger on the none. Step 2, find the prefix you want to get to. Okay, so find what you want. So we want kilo. So I'm going to find kilo. Kilo's here. Then step 3 is count. You're going to count from what you have to what you want. So I'm going to count from number 1 to 2. Step 1 to step 2. So what that's going to look like is step 1 was find the none. Step 2, I want kilo. So I'm going to move 1, 2, 3 to the left. Okay, then I always write it down because I'm going to forget it. So count 1 to 2. Let's put number and direction. Okay, step 4 then is move the decimal. You're going to move the decimal that much, left 3, and that direction. So 1,000 is my number, then with a dot there, that's the decimal. So I'd go left, 3. 1, 2, 3. My final answer will be 1.000 kilograms. Let's do another example. Practice makes perfect on this one. Convert 5,000 milliliters. Okay, step 1. The number I'm given, 5,000 milli, is my start. So I go to my scale. I start at milli. Into liters. Liters is the none. I'm going to none. So I'm going left. 1, 2, 3. Again, left 3. So that's what I'm going to move my decimal. It's 5,000. Left 1, 2, 3. If I'm going too fast for you, rewind it. Watch this again. That's why you have it as a video. Okay. You try number 9. 2.6 liters into nanoliters. Pause the video. Try number 9. So, nanoliters. Either of these is the same thing. So you could have just said 2.6, I'm just going to add times 10 to the 9th. Or you could have moved that decimal over 9 times to the right, and you're essentially adding 8 zeros there. Okay, if you're feeling good about 10, keep going. I'm going to walk you through it though here. So 10,000 meters is my none. Oops. So I start, let's choose a new color, at the none. I'm going to kilo, left, 1, 2, 3. 1, 2, 3, 10 kilometers. Practice makes perfect. You will have more practice on